Hello and welcome to EcoElsa, where I, Elsa, bring you videos to help you and your kids get outdoors. On this week's video, we'll be going over 2 different affordable activities for you to do outside with your kids when learning about weather science. So let's get started. Yes, I know, Elsa's doing weather science, ha ha ha, it's winter. Let it go, let it go. The 2 activities that we'll be going over today are how to build a precipitation gauge and how to tell the weather using clouds. For our first activity, we'll be going over how to make your own precipitation gauge. Now, a precipitation gauge is a device you use to measure the amount of precipitation you receive. So rain, snow, sleet, or possibly hail if your precipitation gauge is strong enough to handle it. What we'll be using for supplies today are a 2-liter bottle, Sharpie, scissors, duct tape, ruler, sand, and water. Using all these materials, we'll be making a precipitation gauge. The very first step is you're going to want to take your 2-liter bottle and find where the vertical edge starts to curve upward towards the opening. Right at this spot is where you're going to want to be cutting all the way around it so that your opening is now the same size of the width of your bottle. This is because right now the current opening for your bottle is too small to accurately measure the amount of precipitation you would receive. So let's cut. Word of warning, it would be easier to use an X-Acto knife when cutting. So as you can see, I've made a small cut along where it is going from flat to curving upward, and now I'm going to cut all the way around, trying to keep it as flat and even as possible. Next, what you'll be doing is taking a thin strip of duct tape and covering up the sharp edges of your gauge. That way you or your kids don't get cut on it. Safety first. Remember, I'm a safety nut, and that's why we're covering this up. I have accidentally gotten cut on them before, hence why I now add in this little extra step, because a plastic cut from a bottle is not a fun thing to experience. Nice clean edges using duct tape. Come on, scissors. Work with me. This is embarrassing. How many blondes does it take to cut duct tape? Don't repeat any of this to anyone. Ha! Duct tape. So, as you can see, kind of sharp and jagged. Like I said, an X-Acto knife works better, but as you can see, scissors can do the trick too. You'll then take your edge and very carefully cover the plastic. The reason why I cut the duct tape is because if I was to use a whole strip, it would cover up way more of the bottle, and then we would have less plastic to actually measure the amount of precipitation you're receiving. Ta-da! Safety rain gauge. Now, as you can see, we now have an uneven bottom to deal with, and we're going to need to level this off with some kind of material, so that way we can get more exact measurements of the amount of precipitation you can receive. Since the bottom is uneven, we would not get exact measurements, so that's why we need to level it off. You can use this, do this using a lot of different materials. For today's video, I'm going to use a combination of sand and water. This is because when I just pour the sand in, there's still going to be air pockets and pores in between the different sand grains, and so I need to fill in that space with water, so that way if I was to get a rain event, the rain wouldn't just fill in between the sand and it would still look like I got 0 precipitation. So, if you want to put a little bit more money into this, sand and water are more affordable. You can always use something like plaster or cement. This would make a more solid, even bottom, which would give you more exact measurements. Sand and water works perfectly fine. The only negative to it is that in the summertime when it gets really hot, you're going to have to make sure that you're keeping the water in the sand because it's going to evaporate. So you're going to just have to be going out there and adding water to make sure you're keeping it an exact measurement. So, we'll be taking our sand and filling up the bottom and then flattening it out. pack it down a little, get rid of all the air. So if you look, I got a mostly even bottom to keep for an exact measurement. Now what I need to do is add enough water to fill in the pores, but not so much that it goes above where the sand is. Looks like I just barely got it. I might have added just a little too much water. So what I'm going to do is I'm going to just add a little bit of sand. Because the important part is having the pores filled in and having it equal. And voila. Nice flat base, saturated with enough water so that I can accurately measure precipitation. Now for the next step, as you can see, I have this sticky part on the back here. So what I like to do is to try to keep that out of the way so I'm not trying to look through it to see the measurement of the precipitation. So I'm going to go to the front and I am going to put my ruler against this and I'm going to do measurements for precipitation. Now, I will start the ruler at where the sand is level here because this is going to be my new 0. Now, for the types of marks that I put on here, it kind of depends on what kind of measurement unit system you use where you live. In the US, we use the US standard system. The rest of the world uses the metric system. So I'm in the US, so I'm going to do it in inches because that's how we measure precipitation here. And it looks like 6 will be right on the black plastic. Okay. So now I have a series of 1-inch marks going up my bottle. I can now go through and put in numbers. Okay. And I can also go through and give it little half marks and little quarter marks. Now the nice thing about rulers is that they have both units on it, usually inches and centimeters. So you could also put centimeters on here so that you and your kids could practice using the metric system as well as the US standard system. Now if I'm going to be using it as a rain gauge, what I'll be doing is taking the cutoff top and placing it inside here so that I can use it to direct the water into the gauge so that way I can get a more exact measurement. I also will be making sure to tape these sharp edges and tape it to the bottle so that way it doesn't fly away if it gets a little windy. Now part of the reason why I'm doing this is so that I can get more accurate measurements of the amount of rain I receive, because this top will help direct the rain into my gauge as well as it will keep it trapped in there because of evaporation. Since you tend to get rain if it's warmer outside, and that means it tends to be evaporation. Now if I want to use this as a snow gauge, what I'd simply do is take this piece out, because the funnel would actually cause the snow to back up here because it would all stick together and it actually wouldn't fall into my snow gauge, so I couldn't actually measure it. So you just remove this piece if you want it to use it for snow. Now what's nice about doing the 1 strip of tape is that I could have a 2-for-1. So say it gets cold enough in the winter that I think it's going to start snowing, I can just pop it like this, and for the most part they usually stay as long as someone doesn't try and grab it or tamper with it. Rain gauge, snow gauge, rain gauge, snow gauge. If you're looking for instructions to help you with making a precipitation gauge in the future, check out a link below to a blog post I did also on the same subject so that you can follow along or print off the directions and use them later on. So there you have it. My very last step would be taking this little buddy outside and placing it in an open area so that I can get equal amounts of precipitation without trees or buildings affecting it. As well as I want to pick a location where it is least likely to be disturbed, whether that's by the wind, animals, or kids. So now that your precipitation gauge is done, let's get outside for some weather forecasting using clouds. Hello and welcome to the outdoor portion covering cloud science. So Unfortunately, it's a bright sunny day. The clouds that were supposed to be here today are not here yet. So I'm going to go over with you the classifications of clouds, and then maybe later on I'll show you some examples of clouds as well in person. So to get started, clouds are usually classified into 4 main groups. This classification was done by Luke Howard in 1803. The 4 groups of clouds are Cirro, Cumulo, Strato, and Nimbo. Now, Cirro stands for the Latin word for curl of hair. And these are the thin wispy clouds that look like hair, otherwise a horse's tail up in the sky. They're usually a little bit higher up. Cumulo are the large, fluffy white clouds that look like cotton balls or cauliflower. They also tend to have a flat bottom, which is where the evaporated moisture collects on the cloud. The third group is strato. Strato is the Latin word for layer, and these clouds tend to blanket the sky and are very broad. The fourth and final group of clouds are the nimbo clouds. Nimbus is the Latin word for rain. So these are the clouds that are mostly responsible for a lot of the precipitation and weather that we receive. However, after Howard had taken the time to break down clouds into these 4 nice categories, he began to notice that clouds came in more variations than just these 4. In fact, many of the clouds he saw looked like combinations of the 4 categories that he had created. So he began naming them accordingly based on whether they looked like a combination of a cirro and a stratus cloud, or a cumulo and a nimbus cloud. You're getting the idea? And he broke these down into 10 more categories. That is a lot of groups of clouds. We will not be going over every single group of clouds today because it would take a long time. I'm pretty sure you guys would find it boring, and nobody got time for that. So what I'm going to do instead is go over with you 4 different groups of clouds that cause different precipitation, and then I'll go over with you a resource that you can use that's free and available online and that you can print off to do cloud science with your kids at home, classifying clouds and using clouds to predict the weather. First are Altostratus clouds. These clouds appear blue or gray and are striated throughout the sky. It's a thick layer, but not so thick that it blocks out the sun completely. The sun appears regularly as dull and fuzzy, not quite with a ring or a halo around it. These clouds can cause a light, mist-like precipitation. Second are Nimbostratus clouds. These clouds appear as a dark gray layer of clouds that are diffused by the snow or rain coming through them. So the bottoms start to get kind of misty and fuzzy looking. Nimbostratus clouds also block out the sun completely. As you can see, it includes nimbo in the word, and as I said previously, if any cloud has nimbo in the word, you can bet that there's going to be rain included with part of that cloud. Our third cloud is the Cumulonimbus cloud, or better known as the thunderstorm cloud. These clouds are very heavy and dense looking clouds that appear in the form of like a mountain or a tower shape with an anvil at the top as they flatten out into a vast plume. These clouds are often on the bottom very dark and also ragged with lots of strands hanging down. This is where a lot of the precipitation is going to come from, as well as potentially hail and tornadoes, since that's what these clouds are known for. These clouds also produce a lot of lightning and thunder, so they're a really good cloud to know and recognize. That way you can stay safe. And our fourth and final cloud type that causes precipitation is stratus clouds. Stratus clouds appear as a gray, uniform bottom, thick blanket of clouds that potentially can have ragged bottoms. Stratus clouds can also potentially cause precipitation if they get thick enough. This precipitation would come in the form of snow grains, ice prisms, or a drizzle. The sun can also be discernible through the cloud, meaning you can see a clear edge to the sun when looking through these clouds, and the only time that a halo would appear around the sun is if you are looking through a stratus cloud at very, very low temperatures. So it is pretty rare that it happens. Usually you only see a halo around the sun when looking at the sun through cirrus clouds. Speaking of which, I think I see some cirrus clouds now. If you look here, we have some really wispy cirrus clouds. See how they look like thin strips of hair or horse's tail, and they're just kind of like fuzzy up there? Now, the last thing I have for you today is a great resource that is available for you online, that is free, that NASA and NOAA put out there for people just like you to use when doing weather science using clouds. It is their cloud chart. Ta-da! So what's great about this is it's not a dichotomous key, it is simply a cloud chart. And how it works is what you do is you look at the sky, you find a cloud, you find a cloud. You find a type of cloud that you see up there, and then you try and best match it to which of the pictures on here it looks most like. As you can see, these are a lot of clouds to go through, hence why I'm not going through all the different types of clouds with you. It's very easy to use and user-friendly, and as you can see, you can print it off as a sheet, but sometimes the words come in a little blurry, which makes it a little hard to read, especially the detailed information underneath each type of cloud. So what you can do actually is you can also access it online, and then when you're accessing it online, you can actually click on different pictures and sections, and they'll show you a couple of different examples of this type of cloud that you can use when looking up at the sky. That way, if you need more examples to be able to discern what type of cloud it is, you can. This is a great resource to use with your kids to do affordable weather science outdoors with clouds, and also is a great introduction to them using keys for trying to figure out what something looks more or less like something else. A great startup for using dichotomous keys and field guides. If you're interested in getting your own hands on this National Weather Service cloud chart, then go ahead and click the description for a link that will take you to the website where I downloaded this PDF for free that you can print yourself or use on the website itself. Pileated woodpecker. What's great about combining these two activities, identifying clouds and keeping track of precipitation, is that it's a great way to introduce your students and your kids to weather science, but also to proper science techniques in general. Because for a lot of different science experiments outdoors, your kids will have to keep track of the weather in addition to whatever it is they're studying. So this is a great strategy to get them introduced. As well as it's very easy to do and very affordable. Your kids will learn how to make observations, how to collect data, and also come up with their own theory based on precipitation in clouds for which clouds cause precipitation and which clouds indicate that precipitation is on the way. So I highly recommend trying this out with your kids or your class. Unfortunately, that is all we have time for today. So I hope you liked today's video. Make sure to like it, make sure to subscribe, and make sure to ring that little bell button. That way you can be notified the second my videos are up on YouTube to help you and your kids get outdoors. If you still have more questions about weather science or teaching outdoors, go ahead and leave those in the comments and I'll help you out as best I can. As well as if you're still looking for more resources, go ahead and click the description. I have links to all my different resources, as well as my email list where I send out a monthly newsletter full of resources to help you and your kids get outdoors. This month's theme is going to be grants and giveaways, so I check that out and make sure to subscribe to the newsletter. There's also links to my different social media accounts. I'm on Facebook, Twitter, Instagram, Pinterest, and a blog, all full of resources and information to help with getting you and your kids out as well. So, as always, I hope you all have a fantastic week. You be safe, learn lots, have fun, and get outdoors. Bye!